Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find area ABCD? Take a moment to study the figure. Then let us uncover the two ideas that make the solution click. Here is the green rectangle ABCD, and its area is what we want. A circle centered at O rests inside, touching the top side at E and the left side at F. On the top side, the tangency point E splits it into two pieces. Segment AE measures 4 on the right, and segment DE measures 5 on the left. These two lengths are our only numbers, so everything is built from them. The whole top side AD is those two pieces laid end to end. 4 plus 5 gives AD equal to 9. One factor in the rectangle's area. The two tangent radii and the rectangle corner form quadrilateral DEOF. We will show it as a square and transfer the given 5 onto the radius. Draw radius OE. At tangency E, it meets side AD at a right angle, shown by the right angle marker. Draw radius OF. At tangency F, it meets side DC at a right angle, giving the second right angle marker. Here is the first key insight. Tangent square DEOF transfers the given length 5 from DE onto radius OE. The rectangle corner and the two tangent radius right angles make that transfer exact, without touching the rectangle's unknown height. Every radius of the circle is 5. Extend segment EO through the center until it meets the opposite side BC at Q, and draw segment OQ. This gives the vertical leg of the right triangle we will solve. Because the top and bottom sides of a rectangle are parallel, the line perpendicular to segment AD is also perpendicular to segment BC. The right angle marker at Q records that fact. Here is the second insight, and this one is essential. E and Q lie on one vertical line, while A and B lie on the other. So the horizontal separation repeats. Segment BQ equals segment AE, which is 4. Now join O to B. Since B lies on the circle, segment OB is another radius, so its length is 5. Triangle OQB is right, with hypotenuse segment OB equal to radius 5 and leg segment BQ equal to 4. Pythagoras gives segment OQ equal to 3. The rectangle height segment AB equals segment EQ. That span is segment EO plus segment OQ, 5 plus 3, so the height is 8. The other rectangle side, AD, is 4 plus 5, or 9. Multiply 9 by 8. 9 times 8 is 72. So the green rectangle, ABCD, has area 72 square units. So the final answer is 72. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.